Students, now we are going to see some application areas of the embedded systems. Okay, so I told you where our embedded system used. Wherever we have seen, wherever the automation is there, in that particular area, the embedded system is there. Okay. Is it audible, ma? So you have seen, these are some application areas of the embedded system I have seen. Now we have a smart TV and all. Okay, so the television is also mainly embedded system. I think you people in the lockdown period, most of the time you are spending the time in mobile and TV and all. So even if you see any of the applications, if you see, keep on seeing on that, that related history will keep on updated. And if you see some movies and all, it will obviously it will check and it will find out you are how much percentage you like. So even it will be linked. So the application areas is television, remote control, mobile phone, and even in mobile phone also we were using the embedded system concept. Fridge, and if you automatically some of the fridge, if even it is in open, you can see some alarm indication. That means we didn't close the fridge properly. So microwave, so obviously we have seen when you set the time and when the cooking is finished, automatically it will indicate. So washing machine completely automated now. We have if you switch on that, it will complete the entire operation. So electric toothbrush. So now we have so many applications where the embedded system is there. Okay, so embedded system means we have seen, I have listed out many applications: electronic tires, medical home equipment. Now we have due to this lockdown, corona and all, even every time we are checking our oxygen level, pulse level. You have some medical home equipment also. Okay, and now we have a thermometer. When you enter into the any places, they will check your temperature. So all are automated. Okay, so this is the main, actually I have listed out something, and this is the major area we are saying: medical systems, of office equipments, tools, banking, transportation, and even in traffic lights. So the embedded system application is, we were facing all our applications day to day life, at all depends on embedded system. Okay, so these are the main specific. Again, it's I have listed out this applications, and this is a broad applications. We are saying in automobile industry, I told you automobiles, very big automatic braking system, everything there, ABS and all that, airbag. Now we have a airbag facilities in the cars. Okay, building systems also, and even smart home is there. So when a person is entering, we can observe who is entering, and we can, and automatically when enter into the house, the light will be automatically on. So everything will be embedded concept. Then agriculture, okay, space for, okay, so there, please students come in the proper time, ma. Okay, every time we were admitting. Yes, okay. Now we will see what is the major components of embedded system. I told you combination of hardware and software. So our subject mainly focused on hardware as well as software. Software means the programming language which supports the processor or controller. Okay, so here hardware means microprocessor. We were using microcontroller, DSP processor. Okay, digital signal processing. I think you have studied this DSP processor in your DSP subject. Did anyone tell what is who is the manufacturer of the DSP processor you have studied? Please, anyone can tell which DSP processor you have studied, ma? Previous semester, students, please. Yeah, Bhavana, can you able to tell? Yeah, tell me which processor you have studied in our digital signal processing, ma? In your 5th unit, you have studied one processor. Did you remember? DSP processor. Which processor? Can you tell the name of the processor?
I don't know, ma'am.
You don't know? Huh? TMS 320C, Texas. That is the processor. Okay, you mute your audio. Ma. Okay, so microprocessor, what you have learned? 8085 and 8086. You have learned in your 5th semester. DSP processor also you have studied. So this subject is mainly we are focusing the microcontroller. Okay. I think this is a basic block diagram of a microprocessor and microcontroller. What is a microprocessor? We used to simply say it is a CPU. So we all know CPU means definitely it have a arithmetic and logical unit, memory unit, control unit. So to integrate the CPU, we need a one input as well as output unit. So this is a basic block diagram. And microcontroller also the same specific function is there, but we can see in detail what is the difference between microprocessor and microcontroller. Okay. Now we will see why microcontroller is very popular in embedded concept. Mostly the embedded concept, they all move on with microcontroller only. Why microcontroller is very popular? Okay, so we will see microcontroller is a VLSI. I think very large scale integrated circuit. Your subject flow you can very well know. You start with the devices, electron devices, on and off. I have taken digital logic circuits. There you have learned logic 1 and logic 0. And then there itself we are move on to the processor, microprocessor, by integrating so many gates, so many flip-flops into a single chip. Okay, depending upon the small scale integrated circuits, medium scale integrated circuit, very large scale integrated circuit. So nearly some lakhs and lakhs of gates will be integrated on a single chip. That will be a microcontroller. So microcontroller will also comes under the VLSI technique. So we are integrating so many number of flip-flops, so many number of memory units, so many number of AND gates, not only AND gate, we are integrating and we are forming the circuit. So embedded concept means definitely a system which contains a memory as well as peripheral in a single chip. Okay, everything will be embedded on a single chip. Everything is embedded on a single chip with microcontroller. So we will see why microprocessor is different from microcontroller. Okay, we'll see the difference. Everything is embedded on a single chip. Okay, that is microcontroller. Okay, I think, is it visible? Yeah, I think. Students, is it visible for you, ma? Yes?
Yes, ma'am.
Yeah, thank you. Okay, now microprocessor and microcontroller. I have listed out the difference. Okay, why microprocessor is not popular in embedded system and why microcontroller is popular in embedded system. In microprocessor, we have a, what are all the, I told you, microprocessor means what? It's a CPU, central processing unit. What it contains, ma? It contains arithmetical logical unit, control unit, memory unit. So if I want to communicate with any other thing, I need a bus, address bus, data bus will be there. Through that, I will communicate. Okay, so that is normally microprocessor. But here, one simple example, in microprocessor, you have studied about so many interfacing ICs. Can you tell, remember the IC names? Interfacing ICs, ma? 8255, did you remember? Actually, it has to be a live.
8259.
Yeah, very good. 8259. Tell me.
8217.
Yeah, 8217. We have studied a PPI, programmable peripheral interface, timer unit. We have a separately, we have a keyboard and a keyboard interfacing. So for each and every IC, if I want to communicate, my microprocessor want to communicate with my peripheral device, I need an interfacing IC. This is the best example when I am connecting my broadband in my home. Okay, I always need a modem. So what modem will do? That will come whenever it will receive, and it is a communicating device between my telephone signal and my laptop or my system. So the same way, microprocessor want to communicate with the peripheral device. It always need a one intermediate device, that is interfacing device. So in microprocessor, you have studied so many ICs, but microcontroller, we don't need of studying any ICs. I think again Tabu's iPhone is going and coming. What has happened, ma? Any network issues there? I think the students please kindly rename. Okay, then only we can understand. Actually, we were coming through Avinash also the same problem. Okay, so microprocessor, everything. If I want to communicate, definitely I need a some interfacing IC. But microcontroller, we don't need any interfacing IC. Everything is embedded on a single chip. So in microprocessor chip, what we have? Central processing unit we have, and then we have a control unit we have, then we have a memory unit is optional depending upon that. But in microcontroller, everything is, we have a onboard memory, and we have a read that is read only memory, read write memory. Have you seen read only memory, read write memory, and timer also inside the microcontroller. IO port 8255 you got studied now separately, that is not needed for here. So input output port is also inside. Then serial interface. So microcontroller means everything is embedded on a single chip. So we don't need of any interfacing IC. So for each, that is very easy to connect with any specific system. So that's why microcontroller is very popular. You are supposed to say what is the difference between processor and controller. Both are CPU. Okay, both are CPU, both have an capability to handle all arithmetic and logical and thinking, everything it has. But microcontroller, we don't have any interfacing IC to communicate with the peripheral. We have every IC will be embedded on a single chip, because microprocessor have been developed in 1970s, 78, 79. After that only we developed microcontroller. But microprocessor, we have studied only Intel processor, 8085 and 8086. Microcontroller also we are going to learn the Intel processor. So you all understand 8080 specifically denotes it's an Intel processor. So 8051, this unit we are going to learn about microcontroller, that is 8051. Okay, so the next we will see next points. I think the next one is microprocessor is also a heart of the computer. Microcontroller is a heart of the embedded. Okay, we were saying that both will act as a CPU, and we told you that memory, IO component have to be connected externally. But microcontroller, we have an onboard memory. So for example, in microprocessor, if I want to control any devices, definitely I need a memory unit separately. But microcontroller, no need of that. I am having some onboard memory capacity. Some that depends upon the microcontroller, it will varies. But some 128 bytes or 256 bytes onboard memory is there. So I can load my program or I can load my data in my onboard memory. So I don't need any external memory. So that is the main advantage in the microcontroller. Can you understand? So that is the third point they specify. And fourth, it cannot be used in compact system. Can you understand? Because microprocessor means we have to go with some separate IC. I have to say go with some memory unit. Everything I have to connect it externally. So the system is not a compact, but it is a very compact system, microcontroller. Okay, this microprocessor is cost of the system is increases. Why? If I want to connect anything, I have to buy all my external peripheral devices. But a microcontroller, I don't no need of any external peripheral. Everything is embedded, so we don't need of any external peripheral devices. So the cost will be very low. So we can easily compatible to use with the embedded applications. Okay. The next one is what the point I have specified in the cost. The same thing is they have given here. Okay, and one more option is in the microcontroller. We have the options. We have the options of power saving mode option is there. In your mobile also you have that option. You can save your power. The same way, microprocessor, if I want to save the power, again I need some external component. I need some external oscillator to control the power. But microcontroller, no need of that. The oscillator itself go into the active mode or go into the idle mode. Automatically power will be saved, because how we were relating the power with the oscillator now. If my oscillator is operating with high frequency, obviously my power is also very high. So to avoid that, we always have a power saving mode, idle mode will be there. So I can save my power in the microcontroller. Okay. Then the next point is okay. Then the point they have specified about this will be, since memory and IO components are all external, again they are repeating the same points only, but with that, okay, here so the speed will be very less. They are telling in external component, if I am connecting microprocessor, the cost will be very high, and each and every time if I am connecting, I can't go save the power. So obviously by going with the external component, the speed is also reduced. So everything is relating with the external component. But microcontroller, we don't have any external peripheral devices. So the speed of the system is also very high, not like a microprocessor. Microcontroller speed is also very high. So you can tell in terms of like this. Okay, by connecting the external component, cost is reduced, speed is reduced, and obviously the by connecting this component, we can save the power also. Okay, and then the next one is, can anyone tell what are the register we have studied in 8085 or 8086? Can anyone tell me? Microprocessor registers, please. I think 701. You muted your mic. I think. Can you able to tell ma? So she unmuted. 35. Jodhisan. Hiroki Jodhisan. Hirok Jodhisan.
Yes, ma'am.
Yeah. Tell me what is some registers in microprocessor, ma?
Sorry?
Any?
Sorry, I didn't catch you.
Registers in microprocessor. You have studied in a microprocessor in your 5th unit, na?
Yes, ma'am.
Tell me some registers. What you have learned? Accumulator. Did you remember? B register.
Yes.
Forgot. Okay, students. I think this long back you forgot your engineering curriculum, everything, man. You have to refresh. In microprocessor, you have to have a primary register is always accumulator. In microcontroller also we have accumulator. Apart from that, we have a B, C, D, E, H, L. I think you have studied BC register, D, E, H, L in 8085. 8086 we have some register, but we have only less registers in microprocessor. Okay, so we can't go for a, so many operations will be there. By going with a less number of register, we have a many operation, but microcontroller have more number of register. More number of register means bank registers. They have for example, one bank they are having 8 registers now, they have 4 banks, so totally how many registers? 32 registers. So bank register alone they have 32 registers. So more number of registers are there. So more number of registers means now our programming will be very much easier for us. Can you understand? So microprocessor, due to less number of register, we have to go for so many logics to move from accumulator to B, and from that only we have to save. That problems will arise. But in microcontroller, we don't have such a problem. We have some bank register, nearly some 32 bank register are there. Apart from that, we have accumulator, B register and all. So we will see in detail where we enter into the microcontroller. Now I am going to tell only the difference. So having more number of register, the program is very easy for us to write. Okay, so that is the next difference. The next one is microprocessor and microcontroller architecture. Actually, this is the popular word they will use. Von Neumann architecture, Harvard architecture. That is the two difference. Don't write any stories while you are writing the difference. Von Neumann architecture, Harvard architecture. Von Neumann, Harvard. What is meant by Von Neumann and Harvard? Now, Von Neumann architecture means we don't have a separate memory for program and separate memory for data. Everything will be stored in a single memory. What is program memory? What is data memory? Now, whatever I am writing coding, for example, move A, B, LDA, LXI, these are all coding. Okay, data means accumulator is 80, B register is 70, C register is 80, that and all data. So, program will also stored in same memory, data is also stored in same memory. That is Von Neumann architecture. That is we are following in microprocessor. But microcontroller, we were moving at the separate concept, Harvard architecture. What is Harvard architecture now? Program we have separate memory. Data we have separate memory. So it is very easy to access. Can you understand? If I want to fetch any program or if I want to fetch any data, it is easy to access because we have a two separate. So Von Neumann architecture and Harvard architecture. Okay, so they have seen Olden days, they use the processors in personal computers. Now the microcontroller we were using mainly, they have told washing machine. Actually, you have one applications, mainly the microcontroller live applications using washing machine is there, because washing machine means I think your day-to-day life you are using washing machine. So microcontroller mainly this 8051 they were using in washing machine. For example, in 8051 they were using in washing machine. I will show one day some real time. I will show the how it is working in program. But here now I will tell you simple example. In washing machine, if I want to connect any motor, you have seen the knob is automatically moving. It is just moving a watch in our dial. So there they will use the stepper motor. Okay, washing, draining, and all. You can see a motor which is rotating with a some high speed. At that times they will use some motor, DC motor, and all. So if I want to connect any stepper motor, DC motor, timer operation will be there. For example, normal wash it will take some 1 hour, 1.5 hours. Some washing it will take some nearly half an hour. Delicate kind of cloth washing it will take. So that timer, counter, everything is in the embedded in a microcontroller. Na? So it will automatically control. So it is easy to connect my stepper motor. It is easy to connect my DC motor. It is easy to connect all my timer and counter. So the microcontroller, the popular application what we used to say na washing machine. So washing machine I can use my microcontroller. Is clear? And again we were moving with this same difference. Okay, I think I told you here what are the functional blocks. What I told you, arithmetical, logical unit, registers, timing and control. But here when I go with that, in apart from that, ALU also there, register is also there, timing and control unit also there. Apart from that, we have embedded like a timer is embedded, counter is embedded, RAM is embedded, that is inbuilt memory I told you. EEPROM, ADC, what is ADC? Analog to digital converter. What is DAC? Digital to analog converter. Everything is embedded on a single chip. So that is microcontroller. So microcontroller means we can simply see whatever microprocessor contains, it is also contains the same thing, ALU, register and all. Apart from that, we have a onboard memory. Apart from that, we have a timer and control unit. Apart from that, we have a timer and control unit means don't think here also it is contained timer and control unit. We have a timer operation, counter operation will be there. Okay, so in this unit we will see what is timer operation, what is counter. That difference you can see very well. Okay, so counting means it will count the clock pulse. Okay, then the next one is bit handling instructions. Bit handling instructions means, for example, one simple example, microprocessor we don't have any bit handling instruction. Rarely in 8086 we can see, but in 8085 very popular. What is bit handling now? If I want to switch on the light, we can say set bit, yes, set B. Set bit means automatically my port will be on. Clear, CLR. CLR means always we have option of clear. Clear means it will off. So we have only one instruction to on the light, one instruction to off the light. If I put set B, my light will on. If I put clear, my light will off. So very easy to handle this bit handling instruction. That's why microcontroller is very popular. I told you I am using my microcontroller in embedded applications now. Due to reduced, actually the instruction comparing to microprocessor, microcontroller the instruction will be very less and powerful instructions are there. One instruction automatically on the light as well as another instruction will off the light. We don't have any interfacing IC between the light and the microcontroller. Okay, and I told you that is we have external memory only in the microprocessor, but microcontroller we have a onboard memory as well as we have advantage of programming memory as well as data memory. So data will be stored in separate memory, programming code will be stored in a separate memory. They've simply said code memory, data memory. Code means programming. Program will be embedded on a program memory. My data will be loaded in data memory. Okay. And other they said that it will be used only for a digital computer system. It is for some specific applications I can use my microcontroller. Specific applications I told you. Now the advantage, not only microcontroller I am speaking. Why we are learning microcontroller now? I think you people have done, you joined in some robotics clubs and all. You have learned about Arduino. Okay, and now Raspberry Pi. So many controller are very popular due to some dedicated application. I can use my processor or controller, some dedicated application I can use. That is the main advantage of this controller concepts along with the processor. Okay, now please see this image. I think whatever I have briefed, that will be denoted in this image. You just see, go through this. Here you have seen, this is the block diagram of microprocessor and this is the block diagram of microcontroller. Please have a look on this. So microprocessor architecture you have studied. We have that entire architecture they have studied. ALU, accumulator, working register, program counter, clock circuit, stack pointer, interrupt circuit. It all put together will be form a one single chip, that is microprocessor. But if I want to communicate with any external device, or if I want to have any memory, I need a external one. Externally, I want to communicate with the microprocessor. But microcontroller, you have seen that everything, you have seen all the IO ports I have. So through IO port, I can directly connect one LED. Directly, I can connect one stepper. But even some, if I want to save the devices, we have some, for saving purpose, some interfacing is needed. But for interfacing IC is not required here. For example, power and control circuits there. Okay, because power circuit will be there, control circuit will be there. In power electronics, you learn that. So if I want to protect my control circuit, we always have some intermediate of that. That is needed. But apart from that, we don't need any interfacing IC between microcontroller and my peripheral devices. So all together, you see internal ROM, read-only memory. We have only option to read. Internal RAM, we have an option for reading as well as writing. ALU is there, accumulator is there. Timer and counter, I told you, timer and counter is one of the, here it will do only the synchronization process will be there. But here you can see with that. Okay, stack pointer, program counter, interrupt circuits, clock circuits, everything will be there. So this is the difference between microprocessor and microcontroller. I think you people have can understand very well about microprocessor and microcontroller. Yeah, students, I think one more diagram I'm specifying microprocessor versus microcontroller. You see, one single word is differentiating microprocessor and microcontroller. For microcontroller, I need only one chip to do all my operation. But microprocessor, for each and every operation, I need a different chip. That is the single word I can differentiate the microprocessor and microcontroller. One chip is enough to do all some embedded application. But microprocessor, for clock I need a separate IC. USART I need a separate IC. Memory I need a separate IC. Or if I want to connect any peripheral device, I need a separate IC. Timer and counter, I need a separate IC. IO interfaces I need. But everything is fabricated in a single chip. That is a microcontroller. Okay. Students, this is, you have any doubt on this, ma? If anyone having a doubt, kindly please arise the doubt, ma. Students? Participants?
Yes, ma'am.
Yeah, you have any doubts? Anshuri Subramanian. Yeah. You have any doubt in difference between microprocessor and microcontroller? What is the difference you observed, ma? One simple difference. Aarti. Aarti unmute her. Ansuri. Yeah, tell me, ma.
SOC and non-SOC.
Yeah.
SOC, system on chip, and
yeah, system on chip. Ansuri is speaking. I thought it is his voice. Yeah, anyone? Ajit Kumar? Huh? Can anyone tell, man? What do you understand? Tell me, even it is in your own language, it's not a problem. Tell me.
Microprocessor is a von Neumann architecture, ma'am.
Von Neumann architecture.
And microcontroller is a hardware architecture.
Very good, man.
and it is a bit handling instruction is less.
In microprocessor.
Yes, no, yes, ma'am. Microcontroller,
Uh,
it have many types.
Many bit handling instructions. Very good, wonderful. Actually, bit handling, I told you, set B is set the bit I can do. CLR, clear the bit. So if I want to on and off, I can use this simple instruction, not only in one port. I can do with all the ports. Okay. Any other from B sections? I think the register number goes back, it have advantage. Huh? Anyone? Sandhya? Sandhya, two Sandhyas are there. 71? So two Nandinis are there, not Sandhya. Nandini? No. Anyone tell? Ajit Kumar told the wonderful difference. Von Neumann, I think you people please have the notes with you, ma. Even I will share this PPT to you. But anyway, while I am speaking, you are listening and all. But even if you take some differences, if the questions will be arised to you, you can answer it. Anyone difference from your side? Please. Pandyarajan? Pandyarajan, yeah. Izad Ahmed is now only coming. Yeah, can anyone tell any other difference, ma? Neetu Priya, are you listening?
Yes, ma'am.
Yeah, tell me one difference. What do you learn? What do you learn from microprocessor and microcontroller? Because in Viva, while we are asking, that is a processor, this is a controller. This is the difference you people will say. But I have listed out so many differences. Yeah, tell me.
Ma'am, for microprocessor, we'll need many external like for example, for connecting an input-output device, we need another processor. But for microcontroller, it is not such. Everything is embedded in a single chip.
Yeah, very good. Thank you, ma. Thank you. Okay. So you people have understand that very well about the difference, because I will go to the course content. In the first unit, the first line of your unit, they have given difference between microprocessor and microcontroller. So that's why I have taken elaborately to explain what is processor and what is controller and all. So that's why we have taken, and now we will see how we were, where we were using this microcontroller and all. Okay, so you just see this diagram, embedded system. In this microcontroller, we have a processor, that is nothing but memory unit is also there, RAM, ROM is there. Okay, IO ports. I told you this all will present in the inside the microcontroller. Okay, ADC, analog to digital converter, DAC, digital to analog converter. So if I want to connect any peripheral devices, through this I can connect. Okay, so this is they have given. So embedded system means a processor which can use ADC, DAC, depending upon the application, the particular signal will be given. So you have seen that while it when DAC, when it receives the signal from the controller, you all know what is the controller signal. Controller is always digital signal will. So once this DAC will convert the digital signal into analog signal. Similarly, if I am receiving any analog signal from the peripheral, automatically my ADC will, what it will do? It will convert that into digital, and it once again it will be processed by the microcontroller. I think this diagram you can see a single chip which have a multiple operation to control. Afridi. These are the applications I have listed out. Okay. Before going into the category of embedded system, we can see that we have a, what is the category? Standalone embedded system will be there, real-time embedded system will be there. So depending upon that, network appliances, mobile devices, these are the categories of embedded. So I told you what are the elements of embedded system. Embedded system, the mainly hardware is our processor. Our processor may be a microprocessor, microcontroller, or it may be a DSP processor. Okay, digital signal. So any processor I can use. So microprocessor, microcontroller, DSP processor. So these are the elements of the embedded system. Okay, now we will classify the embedded system. small scale embedded system, medium scale embedded system, sophisticated embedded system. So these are the three types depending upon the bit. Okay. Now we were seeing difference between microprocessor and microcontroller. The first two unit we are studying about 8051. 8051 is a Intel microcontroller. What is the length of the microcontroller? 8-bit one. Can you understand? It is an 8-bit microcontroller. So small scale embedded systems means they will use 8-bit or 16-bit only. Medium scale means they will use 16-bit or 32-bit only. When I move with sophisticated, they will be many 64-bit processor only. So depending upon the bit only, they are classifying whether it is a small scale or medium scale or sophisticated and all. Okay, and you can understand very well. Small scale embedded system, na, it all battery operated. We are saying our remote and all will be a small thing. Okay, so the little hardware and the software complexity, okay, involve the board level design, and they will use actually in microcontroller. We have a actually the C program is the mother language for all programming language, no? So embedded C is also very popular in microcontroller because it is similar. If you learn C and if you learn about the program machine level assembly level language, by combined together you have a embedded C concepts, so that will be there. Then the medium scale embedded system. So in medium scale embedded system, I told you depending upon the bit we will classify, and we have a both hardware and software complexity will be there. But here we have some editor, assembler and cross assembler will be there. Na? Here we have some programming tool, real-time operating system will be there. IDE, that is one of the popular word in embedded system. Integrated development environment will be there. IDE will be there. So again, we have to co-design our software. Okay. Okay, then this is the sophisticated embedded system. So sophisticated embedded system, again I told you, it's a 64-bit processor. If you are using more than 64-bit only, we will go for sophisticated, and the compiler will be there, definitely will be needed. Okay, and cost will be obviously it will be very high. Again, it will be coordinate hardware and software design will be there. Development tool for this system may not be readily available at actually what here na, here we have a C language coding, and here we have a IDE platform and all. But sophisticated, depending upon the application, they will develop the embedded concept for that. So we can't say this will be specifically used and this will be specifically used. We can't able to mention. Can you understand? So this is, I think, till this we can finish it that. Just I will give some introduction about the embedded system. Then we can directly move on to the microcontroller in detail. Okay. Because now we have seen the difference only. Why I am told the difference in first and all, na? You have to know what is processor and what is controller, because you have already learned the processor. If I am saying microprocessor and microcontroller, you have to know the difference well. So that's why I start the difference. Now I give some small introduction about the embedded system. Depending upon the bit processor, it will be used. Next we will see, next class we'll see and discuss in detail. Okay. Now, students, I think please kindly give your attendance. Register number 5. Please kindly mute and unmute and tell your attendance, ma. 5. 5 is not there. 21. 21. Hey, don't disconnect, ma. Same class, same session will be there. Automatically, the ma'am will. 21. 21. It's not there. 36.
Yes, ma'am.
36 is present. Okay. 47.
Present, ma'am.
Okay. 67. We are checking the attendance parallelly. So 67. No. Okay. 75. 75. 75. No. 75, 76 not there. Okay. 79. 79 is also not there. 84. Okay. Okay. 91.
Present, ma'am.
91 is present. Who's 91?
Anmadi present, ma'am.
Huh?
Anmadi.
91. I'm saying because your registered number is not rolled. Kindly be ma. 91, Vanmati?
Present, ma'am.
Yeah, 91 is that. Please rename your Harshavardhan, Kritika, is here, man? Tabu's iPhone. Actually, that
Tabu.
particular student is coming and entering and leaving, ma. Please kindly rename. Please kindly rename, ma. Yes? Okay. I think. Thank you, students. Tomorrow we will discuss in detail about the embedded system cycle and microcontroller about that. Thank you. Thank you for your patience.
35 present, ma'am.
7 or 2 present.